Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about our Introduction to Scientific Notation worksheet. You can get the worksheet we use in this video for free by clicking on the link in the description below. This video is about our scientific notation worksheet that is about identifying if a number is written in scientific notation or not. Now, scientific notation has two parts. The first part about scientific notation is that it always has a base. Now, this base is always in between the numbers 1 and 10. The second part of a number in scientific notation is that our base is being multiplied by a power of 10. The power of 10 always has a base of 10 and then an exponent that can be either positive or negative. Just to give you a quick example of a number written in scientific notation, something like this, which would be 4.5 times 10 to the 5th power. This 4.5 here is our base, and then this 10 to the 5th power is the power of 10. You can see that the base 4.5 is being multiplied times a power of 10. So let's do a couple practice problems on our Intro to Scientific Notation worksheet. The directions say to state whether each number is written in scientific notation. So you simply have to look at each of these numbers and determine if they are correctly written in scientific notation. If you look at number 1 gives us a base of 5 and then a power of 10, that is 10 to the 6th power. Our base of 5 is in between 1 and 10. That means that this number is written in scientific notation. Number 2 gives us 5.0101 times 10 to the 4th. 5.0101 is in between 1 and 10, and it is being multiplied times a power of 10. So that means that this is also correctly written in scientific notation. Number 6 gives us 0.7 times 10 to the negative 5th. Now this 0.7 is less than 1. So this is smaller than the number 1, so it's less than 1. That means that the base is not correctly written in scientific notation, so this is not in scientific notation. Then the last one is number 7, which is 15.35 times 10 to the 6th. Our base here is greater than 10. That means that this base is not in between 1 and 10, therefore this number is not correctly written in scientific notation. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about how to do scientific notation. You can get the worksheet used in this video for free by clicking on the link in the description below. In order to show you how to do scientific notation, you have to first know the main parts of scientific notation. There are two main parts of scientific notation. It is the base being multiplied times a power of 10. So for example, you could have something like 7.7 times 10 to the 8th power. The base always has to be in between 1 and 10, and the power of 10 is always a base of 10 being multiplied times an exponent. In order to show you how to do scientific notation, you're going to be taking really large numbers, like say 7 million, and rewriting it into the form of scientific notation. Or really small numbers, like say 0.00005, and rewriting it into scientific notation. Now you will notice a few things about our rewritten numbers into scientific notation. Our base here is in between 1 and 10. It did not matter if the number was really large, like 7 million, or if it was really small, like 0.00005. The base remains in between 1 and 10. In order to get the exponent, you have to count how many times you move the decimal to get to a point where the base will be in between 1 and 10. For this number, we moved 6 times, so our exponent was 6. For this number, we moved it 5 times, so our exponent was 5. Now you will notice that this 6 is positive and this 5 is negative. The easiest way to remember if an exponent will be positive or negative is that to get a positive exponent, our starting number is larger than 1, and then to get a negative exponent, your starting number is a decimal or less than 1. So if you look, this number here, 0.00005, is less than 1. It's a decimal, and our exponent ends up being negative. This number, 7 million, is much larger than 1, so our exponent is positive. The first problem we're going to use to show you how to do scientific notation is number 1. So our directions say to convert the following numbers into scientific notation. We have to convert 500 into scientific notation. So we know our decimal starts here. We have to move the decimal to a spot that will create a base that is in between 1 and 10. In this case, if we move the decimal 2 times, our base will become 5. If you moved it one more time, it would become 0.5. That is not in between 1 and 10, so we don't want to use that. So we'll stop right here at 5. Then we move the decimal 2 times, so we know that the exponent on the power of 10 will be 2. And this time it's positive because we started with a number greater than 1. So our solution for 500 in scientific notation is 5 times 10 to the second power. The next problem we're going to use to show you how to do scientific notation is number 3. Number 3 gives us 0.007. The first thing you have to do is we have to take our decimal and we have to move it to a spot that will create a base in between 1 and 10. So if we move it to here, it will create a base in between 1 and 10. So now we have to figure out what our exponent is going to be. Well, if you look, we move the decimal 1, 2, 3 times. So our exponent will be 3 because we moved it 3 times. But we started as a decimal, which is less than 1. So 0.007 is less than 1. And because this is a decimal, that means our exponent must be negative. So our final answer is 7 times 10 to the negative 30. The last problem I'm going to show you how to do scientific notation is number 6. We are given 0.000045. So the first thing we must do is we must move the decimal to a spot that will create a base in between 1 and 10. In this case, we move it to in between 4 and 5 because 4.5 is in between 1 and 10. So this is our base, and we have to include both the 4 and the 5 because they are both a part of the original number. So when you write the base, you have to write 4.5 because it's both a part of the decimal. Then we're going to write our second part of our scientific notation, which is times a power of 10. And then we're going to count how many times we moved the decimal. So we moved it 1, 2, 3, 4, 5, 6 times. So our exponent is 6, but our number starts as a decimal, which means that the exponent must be negative because we started with a decimal. And 4.5 times 10 to the negative 6 is going to be the solution for this. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about our Powers of 10 worksheet. You can get the worksheet we use in this video for free by clicking on the link in the description below. Before we do a couple practice problems on our Powers of 10 worksheet, we're going to go over the basics of what a power of 10 is. A power of 10 is written as 10 to an exponent, and we're just going to write x for the exponent. Our base will always be 10, so this will always be 10. And then our exponent will change. The exponent can be positive or negative. What a power of 10 is really saying is it's telling you how many times you have to move a decimal. So for example, if we have a number that is being multiplied times a power of 10. This exponent is going to tell you how many times you move the decimal, and it's also going to tell you which way you move the decimal. Is it going to move left or is it going to move right? If the exponent is positive, it will move the decimal right, and if the exponent is negative, it will move the decimal left. So let's jump down and do some practice problems on our powers of 10 worksheet. The first problem we're going to go over is number 5. Number 5 gives us 4 times 10 to the third power. Now we know that this 10 to the third power is going to move the decimal that is behind the 4 right here. The 3 indicates that we're going to move it 3 times, and because the 3 is positive, that means we're going to move it to the right. So we will move the decimal 3 times right. So our number is 4. We know that the decimal is located behind the 4 because it's a whole number, and we're going to move it 3 times to the right. So it will go 1, 2, 3 times. Our new decimal will be right here, and any spot that is missing a number, you have to add 0 as a placeholder. So our answer to 4 times 10 to the third would be 4,000, because that's after we've moved the decimal 3 times to the right. Number 6 gives us 7 times 10 to the negative fifth. Now we know that this 10 to the negative fifth indicates that we're going to have to move the decimal. The 5 means we have to move it 5 times. And then because the 5 is negative, that means the decimal will move left. So we will move this decimal 5 times left. So we have our 7. We know the decimal is behind the 7 because it's a whole number. Now we have to move the decimal 5 times to the left. So it will go 1, 2, 3, 4, 5 times to the left. We'll put our new decimal in, and everywhere there's a space, we have to add 0 as a placeholder. So our new answer will be 0.00007. So that's our simplified solution. The last problem we're going to do on our powers of 10 worksheet is number 7. Number 7 gives us 0.835 times 10 to the 6th power. 10 to the 6th power indicates we're going to move the decimal 6 places, or 6 times, and the 6 is positive, so it will move the decimal 6 times to the right. In order to do this, we'll rewrite our number, 0.835, and this time we know the decimal is located before the 8 because it's given to us. And we're going to move the decimal 6 times to the right. So we'll go 1, 2, 3, 4, 5, 6. We'll write our new decimal here, and everywhere there's a blank, we will add a 0 for a placeholder. So our simplified answer will be 835,000. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about converting numbers from scientific notation into standard form. You can get the worksheet we use in this video for free by clicking on the link in the description below. The directions for our practice problem say to convert the following numbers from scientific notation into standard form. Jumping down to the first problem, it gives us 9 times 10 to the third power. So we have to convert this number from scientific notation into standard form. Every number written in scientific notation has a coefficient times a power of 10. The power of 10 tells you how many times you have to move the decimal point. This exponent in particular tells you how many times the decimal point moves, either to the left or to the right. If this exponent is positive, it will move the decimal point to the right. And if this exponent is negative, it will move the decimal point to the left. So let's go ahead and complete this first problem. So once again, the first problem is 9 times 10 to the third power. We already know that the decimal is located right here after the 9 because this 9 is our coefficient. So we're going to rewrite the 9 with a decimal point after it. Now this power of 10 here, 10 to the third power, has an exponent of 3. That 3 is positive, so that means you're going to move the decimal 3 spots to the right. So we will take our decimal place here. We will move it 1, 2, 3 times to the right, and we will add our new decimal. Everywhere there is an empty space, we're going to add a 0 for the placeholder. So to simplify, 9 times 10 to the third would be 9,000 in standard form. So our answer is 9,000. Number 2 gives us 5.01 times 10 to the negative fourth. Now we already know where our decimal is located because it's given to us in the problem. So let's go ahead and rewrite our coefficient as 5.01. The power of 10 this time has an exponent of negative 4. This 4 means we're going to move the decimal 4 times, and because it's negative, that means we move the decimal 4 times to the left. So we'll take our decimal and we'll go 1, 2, 3, 4 times to the left, and we will put our new decimal point, and then everywhere there's an empty space we will add a 0. So our solution in standard form is 0.000501, and that's going to be our answer. The last problem we're going to convert from scientific notation into standard form is number 10. Number 10 gives us 1.00035 times 10 to the fourth power. So we already know where our decimal is because it's included in the coefficient. So we'll write 1.00035 under our problem. Our power of 10 has an exponent of 4. We know we have to move it 4 times, and the 4 this time is positive, so we will move the decimal point to the right because the 4 is positive. So we take our decimal point and we go 1, 2, 3, 4 times to the right, and we will add our new decimal point. Then we're going to rewrite this in standard form. It will be 10003.5 or 10,003.5, and that's going to be our answer. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about adding and subtracting in scientific notation. You can get the worksheet we use in this video for free by clicking on the link in the description below. The first problem we're going to use to show you adding and subtracting in scientific notation gives us 9 times 10 to the ninth minus 2 times 10 to the ninth. When adding or subtracting in scientific notation, you are going to take the coefficients of each number that is being added or subtracted, and you are going to either add or subtract those two together. So in this case we have a 9 and a 2. So these will be what we eventually will add or subtract together. The second part of adding or subtracting in scientific notation that you need to be aware of is that our powers of 10 must be equal. So in other words, the exponent on the power of 10 must be the same. For example, if this was, let's say, 10 to the 7th power, we could not subtract these because this exponent is 9 and this exponent is 7. So we would have to change the 7 into a 9, and once it was a 9, then we could add or subtract. But in the case of our first example, we have exponents that match. So we're going to go ahead and solve this problem. When solving this, we will take our coefficients, which is 9 and 2, and we're going to subtract them from each other. Then we're going to rewrite our power of 10 right next to it. So we will do times 10 to the ninth power. When adding or subtracting, the power of 10 has to be equal. Once the exponent is equal, you will keep the exponent the same in your answer. The next step is to actually go ahead and subtract the coefficients. So 9 minus 2 is 7. And then we will rewrite times and then our power of 10, which is 10 to the ninth power. So our answer in scientific notation is 7 times 10 to the ninth power because we do not change the power of 10 in our answer. Number 2 is very similar to number 1. We're given 3.6 times 10 to the 7th plus 2.1 times 10 to the 7th. So we know we're adding now. we're going to add our coefficients together, which is 3.6 plus 2.1. So we're going to go ahead and write that, 3.6 plus 2.1. Now if you look at our power of 10, our exponent is the same for each power of 10. 10 to the 7th here and 10 to the 7th here. So we do not have to change the exponent on the power of 10 because it is already equal. We will just rewrite 10 to the 7th power underneath of our problem. Then we're going to go ahead and add our coefficients. 3.6 plus 2.1 is 5.7, and then we'll do times 10, and then we'll bring down the 7. So our solution will be 5.7 times 10 to the 7th power. Number 3 is a little trickier because it has one extra step. We're given 7.73 times 10 to the 5th minus 5.3 times 10 to the 4th. Now in this case, we cannot subtract these from each other because our exponents are not the same. So you will notice this has a 4 and this has an exponent of 5. So they're not equal, which means we cannot subtract them. We have to change one of them into the other, and then once they are equal, you can subtract them. The easiest way to change the exponent on the power of 10 is to always make the smaller one into the larger one. So what we're going to do is we're going to change this 4 into a 5. The way we do this is we move the decimal to the left, 1, and we put it here, and then we add 1 to our exponent. So every time you move the decimal to the left, you will add 1 to the exponent. So for example, let's say we move the decimal, instead of moving it once, we move it 2 times. We would then add 2 to this exponent. So it would be 4 plus 2. But if we did 4 plus 2, that would be 6, and we're not trying to make 6, we're trying to make 5. So adding 2 doesn't make sense. So what we're going to do is we're going to move it left 1 time, and then we're going to add 1 because 4 plus 1 is 5, and we're trying to make a 5. So we're trying to make the exponents equal. So let's rewrite our problem now. We know that we have 7.73 on this side times 10 to the 5th power minus, and now on this side we have 0.53 because we moved the decimal left once, times 10 to the 5th power because it's 4 plus 1, which would be 5. So now our exponents are equal. We have a 5 here and we have a 5 here. So we can go ahead and subtract our coefficients. So we'll do 7.73 minus 0.53, and then we'll rewrite times 10, and then our power of 10, which is 10 to the 5th power, because this is what we created to make them equal. Then we'll go ahead and subtract our coefficients. 7.73 minus 0.53 will be 7.2 times 10 to the 5th power. And 7.2 times 10 to the 5th power is going to be our solution. If you found this video helpful, make sure you drop a like. Subscribe to our channel or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about how to multiply in scientific notation. You can get the worksheet we use in this video for free by clicking on the link in the description below. Here we are at our first problem for multiplying scientific notation, and we have to multiply our two numbers written in scientific notation together. When multiplying numbers in scientific notation, you are going to multiply the two coefficients together. So in this case, our coefficients are 9 and 2, so we will multiply these together. And then you will add the exponents of 3 and 5. So just like if you were to follow the rule for multiplying exponents, if we wanted to multiply 10 to the 3rd times 10 to the 5th, we would keep the base of 10, and then we would add 3 plus 5, which would equal 10 to the 8th. So you will follow this same rule when multiplying numbers in scientific notation. Let's go ahead and solve our first problem. 9 times 10 to the 3rd times 2 times 10 to the 5th. So like we already said, we have to multiply the coefficients together. So we're going to do 9 times 2 because we're multiplying. and that's going to be times, and then we have our two powers of 10, which are 10 to the third and 10 to the fifth. So that will be times 10 to the 3 plus 5 because we have to add the exponents. 9 times 2 is 18 times 10 to the 3 plus 5, which is 8. Now 18 times 10 to the 8th is the result of multiplying these together. However, 18 is not in scientific notation. This coefficient here has to be in between 1 and 10. So what we're going to do is we're going to take our decimal, we're going to move it to the left once, and then we're going to add 1 to the exponent. Every time you move the decimal to the left, you will add to the exponent. So for example, if we had to move the decimal 2 times, we would add 2 to the exponent. But in this case, we only have to move the decimal 1 time to make a number in between 1 and 10. So we only add 1 to the exponent. So after we move the decimal 1 time, it becomes 1.8 times 10 to the 8 plus 1, which is 9th power. So our final solution is 1.8 times 10 to the 9th power. Number 4 gives us 4.2 times 10 to the first times 6.5 times 10 to the 9th. So we already know that when we multiply in scientific notation, we're going to take our coefficients and we're going to multiply them together. So we're going to do 4.2 times 6.5 times our power of 10, which is 10 to the first, plus 9, because this one's 10 to the 9th. We will do 4.2 times 6.5, which is 27.3, times 10 to the 1 plus 9, which is 10. Now once again, our coefficient here has to be in between 1 and 10. So we have to take our decimal and move it left once so that it becomes 2.73, which is in between 1 and 10. And then add 1 to the exponent because we moved the decimal to the left. So this will become 2.73 times 10 to the 10 plus 1 power, which is the 11th. And this is going to be our final solution. The last problem we're going to do to show you how to multiply in scientific notation is number 5. This problem gives us 3 times 10 to the 15th times 8 times 10 to the 12th. So once again, we will multiply our coefficients together. We'll do 3 times 8 times our power of 10, which in this case is 10 to the 15th and 10 to the 12th. So 10 to the 15 plus 12. 3 times 8 is 24 times 10, and then our power is going to be 15 plus 12, which is 27. And then our coefficient here is 24. That is not in between 1 and 10, so we have to move the decimal from 24 to 2.4 so that it's in between 1 and 10. And then because we move the decimal left once, we will add 1 to our exponent. So this will become 2.4 times 10 to the 28th power, which is our answer. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about how to divide in scientific notation. You can get the worksheet we use in this video for free by clicking on the link in the description below. In order to show you how to divide in scientific notation, we're going to do a couple problems from our practice worksheet. When dividing in scientific notation, you will take the coefficients of the numbers written in scientific notation and you will divide them. Then you will take the powers of 10 and you will subtract the exponents. So if you can think about when you divide exponents, we know that when we divide exponents, you subtract them. So if you were just given the problem 10 to the 7th divided by 10 to the 5th, you would do 10 to the 7th minus 5. You would subtract the exponents and you would get 10 squared. So this rule for exponents still applies to our numbers in scientific notation here. Even though they're in scientific notation, the rules for the exponent will still remain the same, so you will still subtract these. Number 2 gives us 4.2 times 10 to the 7th divided by 2.1 times 10 to the 5th. we're going to take the coefficients, which are 4.2 and 2.1, and we will divide them. So we have 4.2 divided by 2.1. That is going to be multiplied times our power of 10, which in this case is 10 to the 7th, divided by 10 to the 5th. So we already know that when we divide exponents, we subtract them. So we're going to do 10 to the 7 minus 5. 4.2 divided by 2.1 is 2. And then our power of 10 will be 10 to the 7 minus 5, which is also 2. So our solution to this problem will be 2 times 10 to the second power. The next problem is number 3. It gives us 4 times 10 to the 9th divided by 2 times 10 to the 4th. So once again, when you divide in scientific notation, you're going to take your coefficients and you're going to divide them. So we're going to do 4 divided by 2 times our power of 10, which will be 10 to the 9th minus 10 to the 4th, or just 9 minus 4, because we're dividing, so we're subtracting the exponents. 4 divided by 2 is 2, and then 10 to the 9th minus 4 is 9 minus 4, which is 5. So our solution is 2 times 10 to the 5th power. The last problem we're going to do to show you how to divide in scientific notation is number 6. This problem gives us 9.3 times 10 to the 7th divided by 3 times 10 to the 13th. So once again, we'll take our coefficients, which are 9.3 and 3, and we will divide them. So 9.3 divided by 3. We're going to write times our power of 10, which in this case, we're going to do 10 to the 7th minus 10 to the 13th, or just 7 minus 13. When we divide 9.3 divided by 3, it's 3.1 times 10, and then 7 minus 13 is negative 6. So our solution to this will be 3.1 times 10 to the negative 6th power. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about our rational and irrational numbers worksheet. You can get the worksheet we use in this video for free by clicking on the link in the description below. Before we do a couple practice problems on our rational and irrational numbers worksheet, I want to go over what exactly a rational number is and what exactly an irrational number is. Now, a rational number is any number that you can write as a ratio of two numbers. In other words, any number that you can write as a fraction. The first type of rational numbers are whole numbers. The reason whole numbers are rational is because every whole number can be written as a fraction. For example, if we have the whole number of 6, all whole numbers technically have this 1 underneath of them, because it's like saying 6 divided by 1. We typically do not write this 1 because obviously 6 divided by 1 is just 6, so you do not have to write it. It doesn't change the number. So when you see a whole number, it doesn't matter what the whole number is, there is a divided by 1 or a fraction of 1 underneath of it. The second type of rational number are terminating decimals. Now, a terminating decimal is any decimal that stops or ends. So if you look at 1.75, this clearly has an end point. It's right here after the 5. You can write this as a fraction because you can rewrite 1.75 as a mixed number. So it would be 1 and 75 over 100, which would be the unsimplified version, but it just proves that you can write it as a fraction. The third type of rational numbers are repeating decimals. Most commonly you will see 0.3 repeating, which is 1/3, or 0.6 repeating, which would be 2/3. It's any decimal that repeats the same pattern over and over again. Irrational numbers are numbers that cannot be written as fractions. The easiest way to remember what an irrational number is that it's any non-repeating and non-terminating decimal. The most common examples of irrational numbers are pi, because it goes on forever, And unless a square root is a perfect square, it will be an irrational number. You can see that both of these decimals do not follow a pattern, and the dots indicate that they go on forever, so they never end. Moving on to some practice problems on our rational and irrational numbers worksheet. Now the directions for this part of the worksheet just say to identify whether it's a rational number or an irrational number. Number 3 gives us -8, which is a whole number. Now we know -8 can be rewritten as -8 over 1, and -8 over 1 is a fraction, which means it is rational. Number 4 gives us the cube root of 64. In order to simplify this, we have to find what number times what number times what number equals 64. In this case, that number is 4. So because it's 4 times 4 times 4, 4 is a whole number, which means the cube root of 64 is rational. Number 8 gives us 4 times the square root of 2. Now we already know that the square root of 2 is an irrational number. This is equal to 1.4142, and it goes on forever. When you multiply 4 times the square root of 2, you will get 5.6568, and it goes on forever. Our decimal never repeats, and because of the dots, it means it goes on forever. That means this will be an irrational number. The square root of 77 is not a perfect square, and when you do the square root of 77 in a calculator, you get 8.77496. That goes on forever. This is neither repeating or terminating, so it's non-repeating, non-terminating, which means it is irrational. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about how to simplify square roots. You can get the worksheet we use in this video for free by clicking on the link in the description below. When talking about how to simplify square roots, you have to know what a square root is. A square root is another way of saying what number times itself takes us back to an original number. Another way of thinking about this is to use actual numbers. So if we wanted to find the square root of, let's say, 9, what we would need to find is what number times itself would get us back to our original number, which in this case was 9. There is only one number that when you multiply times itself will get us back to 9. In this case, the number is 3. So the square root of 9 is 3 because 3 times 3 equals 9. Another important thing to mention is this symbol. This symbol denotes when you are finding the square root of a number. This symbol is called the radical symbol. Anytime you see the radical sign with a number under it, what that means is you are looking for the square root of that number. If you see the radical sign and then 16 under it, what that's saying is you need to find the square root of 16. Or in other words, you need to find the number that when multiplied times itself gets us back to 16. In this case, it would be 4 because 4 times 4 equals 16. The last thing I want to mention is something called perfect squares. A perfect square is when you take the square root of a number and the root is a whole number. The square root of 100, for example, is a perfect square because the answer is 10. However, the square root of 56 is not a perfect square because its answer is 7.48. So the square root of 100 is 10, which is a whole number, which makes it a perfect square. And then the square root of 56 is 7.48, which is not a whole number and is not a perfect square. So let's jump down to a couple example problems to show you how to simplify square roots. So when simplifying number 4, it says find the square root of 64. What you're looking for is what number times itself will get us back to 64. In this case, the square root of 64 would be 8 because 8 times 8 equals 64. So our answer is going to be 8. Number 5 gives us a square root of 16. you have to think what number times itself gives us 16. 4 times 4 is 16, so the square root of 16 is equal to 4. The last two examples of how to simplify square roots we're going to show you is number 9 and number 10. Number 9 says find the square root of 36. Well, the square root of 36 is going to be 6 because 6 times 6 is 36. Number 10 says find the square root of 4. The square root of 4 has to be 2 because 2 times 2 is 4. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching. Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about how to find cube roots. You can get the worksheet we use in this video for free by clicking on the link in the description below. When talking about how to find cube roots, the first thing we should mention are square roots. The reason we are bringing up square roots is because square roots and cube roots are very similar. In order to find a square root, you have to find the number that when times itself equals our original number. So like the square root of 9 is 3 because 3 times 3 equals 9. A cube root is very similar to that, except you are looking for the number that when times itself 3 times gets us our original number. So for example, the cube root of 27 is equal to 3 as well, but it's equal to 3 because 3 times 3 times 3 equals 27. Cube roots are also different in the way they look in terms of their radical symbol. If you were given the problem to find the cube root of 125, we would know that we are looking for the cube root because our radical symbol has this 3 embedded into it. Now that 3 means you are looking for what number times itself 3 times will get us back to our original number, in this case 125. If there is no number there, or if it has a 2 there, that means it's the square root. But if there is a 3, that means you are looking for the cube root. In the case of 125, it would be 5, because 5 times 5 times 5 is 125. The first problem we're going to do showing you how to find the cube root of a number is number 1, which says find the cube root of 729. Now when finding the cube root of a number, you are looking for what number times itself 3 times will get us back to our original number, in this case 729. If you multiply 9 times 9 times 9, you will get 729. That means that the cube root of 729 is 9, because 9 times itself 3 times is 729. The last problem that we're going to use to show you how to find cube roots is to find the cube root of 216. Now once again, you're looking for what number times itself 3 times will get you back to your original number, in this case 216. If you were to multiply 6 times 6 times 6, you would get 216. Therefore, we know that the cube root of 216 has to be 6, because 6 times itself 3 times is 216. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching.